For 12.3 day 1, we're going to do more trig, but this time you're going to be given a coordinate, and the terminal side is going to pass through that coordinate, and then you're going to find the 6 trig functions. Alright, so for number 1, they give us the point 8,4, so I'm going to make a very rough sketch of 8,4, and I don't really need to draw the whole x and the whole y axis. We really only care about quadrant 1 because 8, 4 is in quadrant 1. So again, doing a rough sketch, let's say that is 8, 4. Then using that point, you want to draw a triangle. So when you draw your triangle, you want to remember what's called the bow tie rule. If you picture a bow tie looks kind of like that. And then imagine the x and the y axes going through those. Okay, so if your point is in quadrant 1, your triangle looks something like that. If your point is in quadrant 2, triangle looks like that. Quadrant 3, triangle looks like that. Quadrant 4. Okay, so notice that all 4 of those triangles use the x-axis. So the triangle is going to use the point, the origin, and the x-axis. Right, so if I'm drawing this triangle correctly, again, I want to use the bow tie rule, which means use the x-axis, never use the y-axis. Alright, so we know this length is 8, this length is 4. Do the Pythagorean theorem. 8 squared plus 4 squared is 64 plus 16. That makes 80. And what's radical 80? Radical 80 is 4 radical 5. Alright, and I taught you in a previous video that you could reduce it now. That way you don't have to reduce it 6 times when you're writing out the 6 trig functions. So I'm just going to reduce all of these now. If I divide that by 4, I get 2. If I divide that by 4, I get 1. If I divide the hypotenuse by 4, we just get radical 5. Okay, so now I'm going to write out the 6 trig functions. Okay, so sine theta, forgot to label theta on the graph. Theta is always the angle right next to the origin. So theta kind of looks like an O. Theta is always right at the origin. Sine theta, sine is opposite over hypotenuse. So 1 over rad 5. And then rationalize it, you get rad 5 over 5. Cosine theta is adjacent over hypotenuse. So that's 2 over rad 5, which we can rationalize to 2 rad 5 over 5. Tangent theta is opposite over adjacent, so 1 over 2. Now we have to find their reciprocals. Reciprocal of sine is cosecant. So cosecant of theta, when you take the reciprocal, it's easier if you look at this fraction before you rationalize, because then you don't have to rationalize again. Alright, reciprocal of cosine is secant. Again, look at the fraction before you rationalize, and it'll save you some time. Reciprocal of tangent is cotangent, and reciprocal of 1/2 is 2. Okay, looking at all the answers from number 1, you'll notice that they are all positive. And the reason they're all positive is because we're in quadrant 1. So these 4 letters, you might have been wondering what that means. These 4 letters tell you out of sine, cosine, and tangent, what is positive in each quadrant. So in quadrant 1, all 3 of those are positive. And if all 3 of those are positive, all of their reciprocals are too. So all 6 trig functions are positive. Alright, recall when I taught the unit circle, I was telling you guys that cosine relates to the x and sine relates to the y. So if you look at quadrant 2, in quadrant 2, think about a coordinate in quadrant 2. The x is negative and the y is positive. Well, look, sine is positive and cosine is negative. In quadrant 2, x is negative and y is positive. Alright, let's skip to quadrant 4. In quadrant 4, x is positive and y is negative. So what's positive in quadrant 4? Cosine. Right, going back to quadrant 3, x and y are both negative. So if x and y are both negative, sine and cosine are both negative. And remember that tangent is sine divided by cosine. So if sine and cosine are both negative, then tangent will be positive. So if you could remember those letters, a lot of people remember it as all students take calculus, going from quadrant 1 to quadrant 4, ASTC, all students take calculus. Alright, so looking at number 2, the first thing that jumps out at me is both coordinates have a 5 in it. So instead of drawing the triangle first and then reducing, I'm actually going to reduce from the beginning. So I'm going to divide both of these by 5. That'll give me -1, comma, radical 2. Right. I know this point is in quadrant 2, so I'm going to make a rough sketch of that. So -1, comma, rad 2 is around there. Drawing the triangle using the bow tie rule, I need to use the negative x-axis, the point, then go back to the origin. So this bottom length is 1. Some might want to label that as -1, but distance can't be negative. This is radical 2. And if I do the Pythagorean theorem, 1 squared plus radical 2 squared, so that's 1 plus 2 is 3, so the hypotenuse is radical 3. So now we're going to write out the 6 trig functions, starting with sine of theta. So sine of theta equals opposite, so theta is here by the origin. This will be opposite, this will be hypotenuse, and the 1 will be the adjacent. Okay, so opposite over hypotenuse, and we rationalize that by multiplying by rad 3. We get rad 6 over 3. And remembering ASTC, we are in the S quadrant, which means sine is positive. Cosecant, its reciprocal, is also positive, and the other 4 are going to be negative. So for cosine theta, we know it's going to be negative. Adjacent is 1. Hypotenuse is root 3. Rationalizing that one, we get negative root 3 over 3. Okay, for tangent is opposite over adjacent, so rad 2 over 1, I'm just going to write rad 2. And then also remembering that tangent has to be negative. Okay, the reciprocals of those four. Reciprocal of sine is cosecant. So this will be rad 3 over rad 2. Which we rationalize to become root 6 over 2. Reciprocal of cosine is secant. Cosine was negative, so secant has to be negative. And if I just flip this one instead, we get negative root 3. Alright, cotangent of theta. The reciprocal of root 2 is root 2 over 2. Also, you could think about this as adjacent over opposite. So adjacent is 1 over root 2, and then rationalize that. Root 2 over 2. Okay, number 4 is a little weird because the coordinate 0, 4 doesn't fall in a quadrant, it falls in between two quadrants. So 0, 4 is like up here, in between quadrant 1 and quadrant 2. So the book calls that a quadrantal. It's not in a quadrant, it's in between two quadrants. So think about, how did we find the hypotenuse for number 1 and number 2? The way we found the hypotenuse is we did the Pythagorean theorem with x and y. So if you did the Pythagorean theorem with x and y, you would get 0 squared plus 4 squared. Then you have to square root that whole thing, which would go back to 4. So this is your x, this is your y, and then 4 is your hypotenuse. In these notes, they call it the radius. So you could think of this as either the radius or as the hypotenuse. Alright, so sine of theta. Remember, sine is the y. So you take the y coordinate, but you have to divide that by the hypotenuse. So sine of theta is going to be 1. Cosine of theta, cosine is the x divided by the hypotenuse. 0 divided by 4 is 0. So tangent is sine divided by cosine. It's also y divided by x. So when you have 0 on the bottom, that is undefined. Now we need the reciprocals of those. Reciprocal of sine is cosecant. The reciprocal of 1 is just 1. Reciprocal of cosine is secant. So notice secant has a 0 on top. If you flip that and it goes upside down, the 0 is now on the bottom. So that's undefined. Cotangent is y divided by x reciprocaled, so x divided by y. So cotangent is going to have a 0 on top instead of 0 on the bottom. The last three are very similar to the first three we did. Alright, so number 4, I'll draw the triangle for you guys. Number 4 is in quadrant 4. So if that's 6, and we go down to negative 2, we have a point in quadrant 4. Drawing the triangle using the origin, and then always using the x-axis. So this length is 2, this length is 6. Doing the Pythagorean theorem, 36 plus 4 is 40. And then 40, square root of 40 is 2 radical 10. And remember, you can reduce now. It'll save you some time later. Divide that by 2 is 1. Divide this by 2, we get 3. And then divide this, we just get rid of the 2 in the front. Alright, so sine, cosine, and tangent, all of theta. We are in quadrant 4, so cosine is positive, which means sine and tangent have to be negative. Okay, so sine is opposite over hypotenuse. Let's put theta here. Opposite of that, we see a 1 over root 10. So that becomes negative root 10 over 10. Cosine is positive. Cosine is adjacent, which is 3 over root 10. So that's 3 root 10 over 10. Tangent is opposite over adjacent, so that's 1/3, which is negative. Alright, the reciprocals, we have reciprocal of sine is cosecant. Flipping the unrationalized fraction, we get negative root 10. Reciprocal of cosine is secant, so that's going to be root 10 over 3. And then the reciprocal of tangent is cotangent. The reciprocal of negative 1/3 is negative 3. Okay. Number 5 is another quadrantal. So I'm going to do number 5 without drawing a triangle, because it's impossible to draw a triangle. Alright, so doing the Pythagorean theorem, we have our x, we have our y. X squared is 4, y squared is 0. Take the square root of 4, and you get 2. So remember, sine theta is your y divided by your radius or your hypotenuse. Cosine is your x divided by the hypotenuse. Tangent is y divided by x. So 0 divided by negative 2 is 0. And now we take the reciprocals. Cosecant. The reciprocal of 0 is undefined. The reciprocal of negative 1 is negative 1. And the reciprocal of 0 is undefined. Okay, let's try this one without drawing the triangle. It is in quadrant 3. So if you do, that's a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. So this is your x, this is your y. Your hypotenuse or your radius will be 5. Alright, in quadrant 3, ASTC. In quadrant 3, tangent is positive, so these two are negative, which means for the reciprocals, cosecant will also be negative, secant will be negative, and cotangent will be positive. Alright, sine is y divided by the hypotenuse, so 4 over 5. Cosine is x divided by the hypotenuse. Tangent is y divided by x, and because they're both negative, it becomes positive. Let's box these answers. Alright, reciprocal of negative 4 over 5 is negative 5 over 4. Reciprocal of cosine is secant, so negative 5 over 3. Now we take the tangent, flip that, and we get 3/4. Okay, that is all for the first half of 12.3.